We are doing Convergence of Series Part 1. So in the 3 different parts that we're going to do, we will go through the steps. I will explain to you how to go through steps to make sure how to check that a series is convergent or divergent. So what do I mean by steps? You will always use the first step, divergence series test. Then we will, for instance, do the different types. Later on, we're going to do the ratio test and the integral test. And then much later in the third video, comparison and limit comparison. So in this video, we're going to focus on the divergence test, and then the 2 types, the P series and the alternating series. But just to make sure you understand why we are doing convergence of series. Now in my videos on L'Hopital's rule, I'm sure you've noticed it's all about finding the limit of a sequence. And then in my videos I did explain the 7 indeterminate forms that you can use. And then, for instance, here we see that we get infinity over infinity, and if we derive, we get a half. So that was very important for sequences. But in this video and the 2 after these, we're going to check whether or not a series is divergent or convergent. So just to clarify what we will be working with. So there is our series to infinity. What does that mean? That we're adding these terms to infinity. So different from a sequence where we just had these terms up to infinity. So if we add these terms infinitely, we get an infinite series. Now, what is just very important to understand for later is the partial sum, the nth partial sum. So if I have my series and I add to infinity and I take a part of that sum, hence partial sum, I call it the nth partial sum. So as you can see here, I only add up to a n. So if I then take the limit as n approaches infinity of that partial sum, and that limit does exist and is a real number, then my series to infinity will be convergent. But more on that later. So just remember, if you can't find the sum of a series, we call that series divergent. So let's start with the divergence test. We're going to start with our first step. So just remember, I break it down in steps so that you can identify easier in the test and exam which test to use. So my order is not the same order as what you've done in class, but I strongly recommend that you do follow these steps when you're in the test and exam. So let's go over the divergence test. The divergence test says, if I look at the limit of the sequence, be careful here, the limit of the sequence, and it is not equal to 0, or the limit does not exist, then my series is divergent. So that is what the divergence test is saying. So more on this just now when we do examples. Just one thing I want to clarify here. If we have statements in maths and A implies B, it does not necessarily mean that B implies A. Not necessarily. So what do I mean by that? If I say the limit as n approaches infinity of my sequence is 0, does not exist, then my series is divergent. It does not say that if my series is divergent, that my limit will not be equal to 0 or will not exist. So you cannot say the converse is true. You can also not say that not A will imply not B. So what do I mean by that? You cannot say that if the limit of the sequence is 0, that the series is convergent or divergent. This is extremely important for what's coming. If the limit of the sequence is 0, there's no conclusion, and we will continue with our steps. But more on that also as we do the examples. Now just remember what I've just said. If you have a statement A implies B, you can, however, say that not B implies not A. What do I mean by that? If I take my statement here, there's statement A, there's statement B, that the series is divergent. So what is the negation of that? So I can say if my series is convergent, if my series is convergent, then my limit of my sequence will be 0. These statements are very important for what's coming, but I will mention it again as we go along with examples. Let's start with example 1. Now, remember what I said, we're going to strictly follow these steps. We've only done our divergence test, so you know we can only do a divergence test. Let's quickly go through it. They say use the divergence test here to determine whether the series is convergent or divergent. So here they tell us divergence test, but when you in the test, I strongly recommend you immediately, step 1, do the divergence test. Now, what does the divergence test say? What did we just read? So, just before I say that, please remember that this part will always be your AN. So that is your sequence. What did the divergence test say? We're going to do the limit of the sequence. What do you see here? We have infinity over infinity, which is an indeterminate form, and for that reason we're using L'Hopital's rule. So please remember that L'Hopital's rule is going to be very important. If you're not familiar with it, I strongly recommend that you first do those videos, 2 videos on L'Hopital's rule. For L'Hopital, I need to change my sequence to a function. You have to do it whenever you do L'Hopital. So, how does L'Hopital work? Derive top, derive bottom. When I derive my numerator, I get 1. When I derive my denominator, I get 2. And hence, my limit will be a half, which is not 0. What does the divergence test say? If the limit of the sequence is not 0, then the series will be divergent. So the corresponding, we'll just change that to series is divergence. And please remember in the test, you need to say by the divergence test. Let's do the next one together. So we have again the series. You want to check whether or not it is convergent. We do the limit, we change to x's, and we see that we get infinity over infinity, indeterminate form. We use L'Hopital. Now, do not make the common mistake that students make. As I've said in my videos on L'Hopital's rule, do not make the mistake to derive the whole function and therefore use the quotient rule. Do not do that. Make sure you avoid that mistake. What do you know by now? You have to derive the top and the bottom. And just to clarify here, I've times the top out. Derivative top, bottom, 2x plus 2, 2x plus 2. My limit is 1 not equal to 0. Therefore, from my divergence test, it will mean that my series is divergent. Now, just remember what I said now before. If you, for instance, do this series, let's just use that one, and you use the divergence test. You first look at the limit of the sequence. Now, because you do L'Hopital, you're going to change to x's, but since you get infinity over infinity, you're going to use L'Hopital. So what do I get here? I'm going to derive twice rather, because when I derive the first time, I still get L'Hopital. When I derive the second time, I will get the first time I'll get for the denominator 3x squared, second time 6x. And what will this approach? As x approaches infinity, the whole fraction will approach to 0. What did I say earlier? Since the sequence is approaching 0, I will not assume anything. I will continue with the steps, but more on that also later. Now we are going to P series. P series is a type. Remember, we did divergence test. Now, first step, second step, we're going to look at the two types. We're going to look at our P series type. This one quite easy. We're going to just go very quick through it. This is the form. Hence, the reason why I call it types, because you have to look out for this particular form. If your series is in this form, you will do P series. Now you have to learn what you have to learn about the P series. So if P is greater than 1, our series is convergent. If P is less than equal to 1, our series is divergent. Let's look at this example. Remember, we will always write our root in exponential form. By now you know that the cube root means n to the power of a third. Now there I have my form of my P series. Why? Because there's my P, and P is less than 1, since it is a third. Now P less than 1 means that my series is divergent by the P series. Also, more on that later. P series is going to be very important when we use the comparison test. Now, our next type that we can use is the alternating series. Now, whenever you see something in this form, it can either be that or this form, n minus 1, n plus 1. It means that my series, when I add the terms in the series, they will alternate, plus, minus, and hence the name alternating series test. Now, when I get something like that, I will do the alternating series test since it's in that form, but there are two conditions. Now, for the conditions, you only gonna look at your sequence, AN. Now, those terms must be decreasing. Now, I'm sure you remember from first year, decreasing means that AN plus 1 is less than equal to AN. Remember, to show decreasing, you're not allowed to use an example to show that it's decreasing. You have to use this to show decreasing. The other thing you can use, but it is a bit harder, you can show that this is less than equal to 1. So more on that when we do an example. Then the next condition, the limit of the sequence must be 0. Then the series is convergent by the alternating series test. So to recap, when you see anything in this form, you're going to try the 2 conditions for the alternating series test. Now, just to mention, remember I said we're going to follow these steps strictly later, but there is an exception. If you see that something looks like an alternating series, you can skip this step first, then go straight to your alternating series. And if the alternating series test fails, we will go back to the divergence test. But also more on that later when we do an example. So let's look at our first example. You can all see here, it looks like since we have -1 to the n, it looks like we can maybe use the alternating series test. So what's the first condition? We need to check that an 1 over root n is decreasing. We need to check this. But we know, so just make 100% sure you are familiar with this. So an plus 1, you replace n with n plus 1. I often see that students do not know this. Now you have an plus 1 less than an. You want to see if it is true. Now you can use what I've said here. Remember, the bigger the denominator, always the smaller the fraction if your numerators are the same. What else can you do? You're going to check if this is true. So I'm going to cross multiply. We can normally not cross multiply in inequalities. Why can we here? Because we know that n is a natural number, so n is positive. Hence, we can cross multiply. I often see students don't know this, so let me just make sure you know this. So if all my terms are positive, I am allowed to say that. This is very important also for later. Now, let's go back here. Why is this true? You can see for natural numbers that since we have n plus 1 greater than n, the square root of n plus 1 greater than root n, and we know it is true that our sequence is decreasing. What is our second condition? We check this limit. From the first video, you're all familiar with this. As n approaches infinity, my bottom is getting bigger. I have a constant in my numerator, so my fraction is going to 0. Hence, the 2 conditions are satisfied, and hence, my series is convergent by the alternating series test. Please just make sure in your test and in the exams you do say that the series is convergent by whatever test you're using. Now the next example is very, very important. We want to know whether or not this series is convergent. So now students see this, they immediately start with the divergence test, because I've mentioned you must do the steps, but I want you to remember for the remaining of this year, it's going to come up often, even when we do Fourier series later in the year, that cos n pi is always -1 to the n. Why? Let's just check this out. If we do the cos graph, we will alternate between positive 1, negative 1, positive 1, and it continues like that. So it alternates. So please remember from now on, because if n is 1, cos pi negative 1, n is 2, cos 2 pi 1, n is 3, negative 1, and so on. I want you to really study that. And hence, you should see in the test cos n pi is negative 1 to the n. And we're going to test the alternating series test. So make sure you are confident with that. So what are our two conditions? We're going to check if the sequence is decreasing. So we want to check this. Now, like I said earlier, students often make this mistake. So if an is 2n plus 1, now I need to get an plus 1, so I will substitute n with n plus 1. So I will get 2n plus 3 in my denominator. What do I see again? Since my numerators are the same, the bigger my denominator, the smaller this fraction. Very important also for later. So I am correct. My sequence is decreasing. Let's do the second condition. The limit as n approaches infinity, 1 over 2n plus 1. The bigger the denominator, constant numerator, my fraction will approach 0. Hence, the two conditions are satisfied and my series is convergent by the alternating series test. Let's check out the last example for now. So again, we have the series. What do you see in the exams? You recognize the minus 1 to the n. It could be alternating. You for now skip the divergence test. You go straight on to the conditions for alternating series test. So let's just check. If an is 3n over 4n minus 1, an plus 1, you replace n with n plus 1, hence you get 3n plus 3 divided by 4n plus 3, and you want to check if an plus 1 is less than or equal to an. Now, we haven't had one like this before. What can you do? Remember, for this test, for the test and exam, because all the terms are positive, you are allowed to cross multiply. That's what I have done here. So what did I do? I crossed. So always cross from left top and less than or equal to that. Then I just FOILed. I'm not gonna do the steps there. You should all be familiar with that from grade 9. And I end off with this. Now, is this true? Yes, it is. Why? Because these two are exactly the same. Here I have plus 0 and minus 3 is less than 0. Therefore, it is true. But now I need to do my next condition. I need to look at the limit as n approaches infinity, just of the an. What do you see here again? You don't have to use this method that I've done here. You can still do L'Hopital. If you derive top and bottom, you get 3 over 4. What do you see? Condition 2 of the alternating series is not satisfied. Now, please don't make the common mistake students make. They will say if a condition is not satisfied of the alternating series, that the series is divergent. No. If one of the conditions of the alternating series test is not satisfied, we immediately go back to the divergence test. Now, what did the divergence test say? The divergence test said that I must take, if I have a series n1 to infinity, I need to take that whole term in my sequence and I need to do the limit. So don't make the common mistake students make here. They will only take the 3n over 4n minus 1. No, remember we are doing the divergence test where we will take the whole term from the series. But now, we haven't had a limit like that before when we had minus 1 to the n. Please do not make the common mistake students make by assuming it is L'Hopital. No, because of the minus 1 to the n, you cannot use L'Hopital. What do you always do in a case like this? You will check when n is even. Now, you should all know from last year, first year of school, minus 1 to n, if n is even, is always plus 1. And then minus 1 to the n, if n is odd, is always negative 1. Hence, why I have done this. If n is even, my minus 1 to the n is just 1. I just have this. Then from L'Hopital, I get 3 over 4. If my n is odd, I have minus 1. So then from L'Hopital, I get minus 3 over 4. Since the limits are not the same, the limit does not exist. That you can also remember from first year. If we do a limit and we get, say, L, and sometimes negative L, the limit's not the same, so it does not exist. And since the limit of the sequence does not exist, the series is divergent by the divergence theorem. Remember we said for divergence theorem, two things. If the limit of the sequence is not 0 or the limit of the sequence does not exist. Students often fail to see that you also have to look out for this. Then the series is divergent. So that is quite a mouthful on convergence of series, the first two steps. So to recap, when you get a series, you will immediately do the divergence test unless you can or you think that it might be alternating series, then you will first do alternating series. The types P series must be in this form. If P is greater than 1, the series is convergent. P less and equal to 1 series, divergent. And then the alternating series with the two conditions. In the next video, we are doing the ratio and the integral test. So please look out for the next video, part 2, on convergence of series.